All right, now we're going to look at example 2, finding the missing terms. So like I said before, arithmetic sequences, it's a list of numbers. You can see here, list is separated by commas. And those to get from one number to the next, we have to add some common difference. And so let's see, what does it take to get from one to the next? Oh, I don't actually know. And so the idea here is, I guess we need to find out what our common difference is. So if I go from here to here, I know that I have to add some sort of common number. So it gets me a D there, and then I know I should maybe add another one to get to here, and then another one to get to there. And then if I take 12 and I add another common difference, I'll get to the Z, and I guess if I work here, I'll have to subtract Z to get over there. Now keep in mind, I write down that I'm going up plus some sort of difference, but it's possible for this difference, this D, to be a negative number. In which case I'll be adding a negative number, same thing as subtracting. And over here, I'm subtracting a negative number, which is the same thing as adding. So just because I write plus doesn't mean it's always going to be a positive number. So all I know here is that if I have 24 and I add a D, add a D, add a D, I should get to 12. So if I have 24 and I add a D, a D, a D, I should get a 12. So I have 24 plus 3 D's should get me to 12. And now this becomes a simple algebra question. I need to get this D alone, so I'll subtract the 24. And 3D equals negative 12. And then I can divide by 3 and divide by 3. So my D equals negative 4. Okay. So this is what my D is. My D is negative 4. That's what my common difference is. So I know that I started with 24, and then I had some blanks, and then I had a 12, and I had another blank here, and then I think I had a blank at the beginning. And so to get from here to here, I have to add negative 4. So I have to add a negative 4. And 24 plus a negative 4, which really is just a negative 4, 24 minus 4 is going to be 20. And then I can minus 4 again and get 16. And sure enough, I can minus 4 again and I would get 12 like it says. And if I minus 4 one more time, I should be able to get 8. Now working backwards, you're going to have to change the symbol. So in this case, I'm going to have to add it. And the reason is because I'm working backwards, I'm going to subtract. So if you're subtracting the common difference, which in this case is a negative 4, you're subtracting a negative 4. That's the same thing as adding. So we'll go plus 4, which would then be 28. So this would be a plus 4, which would get me 28. So that was my W, X, Y, and Z. So we got to find that common difference, and then we can work all the way through. Okay, so let's take a look at the next one here. Maybe I'll just zoom out in case you need to take a look at all of this here. Okay, so 53. 53 and then an A, B, C. So I'm at 53. I know I'm going to have to add a common difference to get to A, add another common difference to get to B, and then to get from here, we're going to add another common difference to get to C, and then there, I have to add another one. So I have to go, if I have 53, I have to add 4 D's, and then if I do that, I should get my last term there, which is 25. So I have 53 plus 4 D's should get me 25. So just some basic algebra here. I will minus the 53, minus the 53. So that's gone. So I have 4D is equal to 25 minus 53, which is negative 28. And then divided by 4 and divided by 4. So D is, I guess that's a negative 7. So, okay. I was going to do that, I think, in red. Why? Because I don't know why. So I know that I was at 53. And then there was 3 gaps here. And somehow I got to 25. So I guess if I minus the 7 from every one of these, hopefully that gets me there. So 53 minus 7 would be 45. Nope, 46. Minus 7 is 39. Minus 7 is 32. Minus 7 is 25. Okay, good. So that's my A, that's my B, and that's my C. So I will zoom out here for you to take a look at what we have, and we'll go from here. Okay, so 8, I don't know the difference, so I know if I add D, I'll get to X, and if I add another D, I'll get to Y, and if I add another D, I will get to 10. So if I'm at 8, and I add 3 D's, so just a D plus a D plus a D. By the way, you don't need to write this all the time. If you wanted to, you could just go right to 8 plus 3 D's is equal to 10. Okay, so minus the 8, and then that's gone. So 10 minus 8 is 2. So 3D is equal to 2. So if I divide by 3, I'm going to get 2/3. So D is equal to 2/3. That's why, like, when I was looking at this, I thought, okay, well, 8 plus 1 is 9, plus 1 is 10, plus 1 is I would already be too high. So it had to be a number less than 1. I didn't quite know what it was going to be. It turns out it's 2/3. Okay, so we need to get X and Y here. So I have 8, and then that, and then that, and then 10. That's my X and that's my Y. Now, I mean, this is probably, I have a little bit of room here. I don't, off the top of my head, know what 8 plus 2/3 is. So it is adding, yeah. So I'll just add 2/3 here. And same with whatever that number is, which will be Y. I don't know what it is, but I'll have to add 2/3 to that as well. Okay, so this is 8, but this is really 8 over 1. So times that by 3. So 24, 1 times 3 is 3, plus a 2/3, which is 26 over 3. Okay. And so if I'm at 26 over 3, and I add a 2/3 to that again, I should get my Y. So that's going to be 26 plus 2 is 28 over 3. And if I add 2/3 to that, just out of curiosity, if I add 2/3 to that, 28 plus 2 is 30 over 3. 30 over 3 is 10. Sure enough, my last term is 10. Okay, so those are my two terms, 26 over 3 and 28 over 3. Maybe not as intuitive, it wasn't a nice whole number, but it was done in exactly the same way, just with some fractions. Okay, so we have the last one here. So I have 3 over 2 plus some D to get to here. And if I add another D, I'll get to F. And if I add the same D again, I'll get to G. And then lastly, add it to here, and I'll get to 9 over 2. So what would that be? So if I have 3 over 2, and I add 4 D's, which again, you could just go plus 4D, which I'm doing in just a moment. 3 over 2 plus 4D should be 9 over 2. 4D is equal to 9 over 2. So first we got to subtract 3 over 2. And it looks weird when I do that. So then those are gone. 4D equals 9 over 2 minus 3 over 2. So you subtract the numerators. 9 minus 3 is 6. Denominator stays the same, which is just 2. So I guess 6 over 2 we can reduce to 3. And then divide by 4. So I've got d is equal to 3 over 4. Okay, well that is a weird number. I mean, it's a nice fraction, I guess, but it isn't a nice whole number like I was hoping for. So that's a 3 over 2. Then we've got a number. How many numbers do we have? I think I wrote this a little too high up here. So 3 over 2 plus a number, plus a number, plus a number gets me, what? 9 over 2? Just double checking that. Yeah. And is that E, F, and G? Yep. That's E, that's F, that's G. So E, F, and G. So that's what I need. So I know that if I have 3 over 2 and I add 3/4, I should get my next number. Now, unfortunately, those aren't a common denominator, so I'm going to multiply the 3 over 2 by 2, so 6 over 4 plus the 3/4 is 9 over 4. So if I have 9 over 4 and I add the 3/4, this is nice because I already have a common denominator. I have 9, 10, 11, 12 over 4, which can reduce, but I'm going to keep it as 12 over 4 because I'm going to add a 3 over 4 to that. And 12 plus 3 is 15 over 4. Now that can't be reduced. So that one is there. However, this thing is a 3. So those are my numbers. 9 over 4, 3, and then a 15 over 4. So I'll just zoom out here if you need to take a look. Well, I can't apparently box that answer, so I'll just erase it. And then I can zoom out here. So maybe not as intuitive. This one had some fractions in it. These last 3 numbers required a little bit more work. But other than that, it was actually pretty straightforward.